Welcome to Menon Thoughts, where technology, life, and growth comes together with purpose. I'm Govin Menon here to walk you through the challenges of your career and times of healing. This is episode 2 of our series Build the Software the Right Way. Today's topic, I think one of the most crucial and probably most misunderstood aspect of software success, architecture. How do we architect our software product or a project in a manner where it can last? So before we write a single line of code, we need to answer one of the critical questions, right? That is what I believe. How will the system hold together when it grows? That is where the software architecture steps in. It is not just about tech stacks or diagrams, context diagrams and all. It is about setting a foundation of the 3 S's, as I say: simplicity, scalability, and long-term sustainability. That is where a software project or a product has to be architected or needs to be architected so that it can grow, it can scale, it can sustain itself over a period of time. Think of architecture like a blueprint of a building. I keep using that analogy a lot with my teammates, right? Probably I wanted to become a civil engineer and became a software engineer, but still, at the subconscious level, I keep referring it to building a software is like building a home or a house, right? You may be able to change the furnitures, or you may be able to paint it later. You might be able to even do some exterior stuff over a period of time. But if the foundation of it is weak, the structure will collapse under the pressure, right? Over a period of time. So like, for example, let's say you built a foundation where you initially thought you need only a single floor house and you cut your corners on the foundation. It doesn't cost you much to put a bigger foundation if you really look at it. From building a house concept, you can go and take a foundation for, let's say, 3 floors and still build 1 floor, and then you can build the second and the third floor later. But most of the times what happens is when you're building a house, we do look at these things and we say, okay, let's future proof it for at least the next generation, and see if we can actually have a bigger foundation made, right? But in case of a software, that is missed out in most of the times because of the pressure. One, the pressure with which we try to deliver the projects, and 2, probably we don't look at it from a longevity point of view, or the term frame of saying that it will scale, or if the product becomes successful, it can scale, it can attract more customers, it has to live its own life, right? People tend to forget that at times, right? So good software architecture defines, actually, according to me, data flow, the component boundaries, communication patterns, technology choices, and the trade-offs, right? This is what a good architecture would be, right? But if you talk about bad architecture, that is technical depth that waits to explode over a period of time. So keep this in mind. When you are actually building, if you have these 4 things very clearly defined in terms of the data flow, the component boundaries, the communication patterns between these components, technology choices that you're doing with trade-offs, what trade-offs you're doing for each technology choice that you're taking, then you might be able to get a good architecture in place. So let's simplify this into 3 S's that I was talking about at the beginning, right? So according to me, there are 3 things which are there, which if you keep as your core principles, it will help. Simple, scalable, sustainable, right? These 3 things, if you keep it in your mind, you would be able to achieve what I just described as a good architecture, right? Okay. So let me break it down a bit, right? So let's say, let's take the first one, simple, right? I mean, what is simple? Avoid over engineering your architecture. Stick to a clear responsibilities like solid principles, or pick up a principle and then follow that, right? Scalable. Can the system handle more than the users, the data, or the requests without major changes? So always assume that your software will succeed, right? And there is always a possibility of that software to actually grow, attract more users. E-commerce is a good example. To start with, you'll always think about it, okay, we are going with a smaller scale, and then when it grows we will see. But look at the time of architecture, whether with minimal changes or with not major changes, can it scale up, right? Can we add Kubernetes, can we add the K3 clusters? Can we add multi-threading? Can we have those sort of things built in the core principles itself when you're architecting it, right? Use modular design wherever possible, messaging queues, async processes whenever needed. This will help because most of the applications that are built now are web-based. I would not have said this 10 years back. When there were monolithic applications, we would not be looking at it in this pattern. When we were doing in COBOL, it was a different pattern that we used to follow. We never thought about scaling because it used to be internal systems, internal servers, and you had restricted number of users that will come in, say 100, 200, 300 users maximum. Now you're talking about scale where you have got millions of people coming and hitting your application. There's a good possibility of that, right? Even if it is, let's say, a thing like, let's say, internal task management system that you're building as a competition for Jira or Atlassian or whichever you want, Jira of Atlassian or Asana or whatever. When you are actually building your product, if you say you want to build it internally or bring it into your organization and build your own tracking management system, think of it as an eventuality that it might be a product which you can probably sell to millions of users later, right? That's how you start building it. Even if right now you're catering to 10 users or 15 users or 20 users or 30 users, think of it how you can expand that particular product, or what is the possibility of expanding that product into a level where it can become a bigger product and probably a SaaS or a PaaS, right? So for that you need to look at scalability. Sustainability is the third factor that I normally consider as most important. While the team is currently able to cope with the technology, currently able to probably use the latest and the best technology, what is there, will this team be able to maintain and evolve it over a longer period of time? So for example, like if you want to pick up, let's say your team has got 4 or 5 people, right? And 3 of them know Angular at this point, and they have worked on Angular, say 8 or 9. You might say that, okay, let's go with Angular 9 now, right? But over a longer period, if these 3 people go off, or let's say you get more team members who do not have the knowledge of Angular 9, but they are better off with Angular 13, it might be a bad choice you have made right at the beginning, right? Probably this is one-off scenario that I'm talking about, but there are a lot of such scenarios. Like, I mean, probably you will go with a trend and say, okay, let me build it through, say, AI bot, lovable AI or whatever. You will build it. It will give you a good result also, right? With the current technology. But did it use the right tech stack? You don't know that, right? I mean, so you probably have to look at that from that point of view, whether it is sustainable for a longer period. Do your team has the required skills and resources to maintain it through its cycle and the future cycle, extended life cycle that product might require. Consider documentation, TDDs, testability, and onboarding for new developers right at the beginning. Make sure you have got enough documentation in place, enough technical documents. You have got TDDs written very well, so that even if somebody goes and breaks that particular code, the new developer goes and breaks it, it is caught very early. That is how you can keep the sustainability part of it going. So from out of all these three things, one of the main thing that I believe, as an architect, because I've been working as an architect for some time now, architecture should not intimidate the the users, the developers. It should enable them. So I'll give an example. I mean, I was working in between for Air India as a consultant, and there they had such a vast stack, right? I mean, because each team worked in a manner and each team had their own architect, which were not talking with each other. There were applications which were running on AWS with Angular and with say Java at the back end, and there was just 2 rooms away in another another silo there is another team working. They are both working on different functionalities. Obviously their functionalities are very different, but that team is working totally on React and .NET Core at the back end on Azure, right? Now, not a problem. Both have got different silos working, and they have got different functionalities, and they're probably different core teams working on different functionalities at this point. But at some point, if these teams go and work in collaboration and then say, this set of people are going to work with this particular product and say the product A, and the people who are working on product B are going to be supporting product B, or even one single person moves around, that particular person will be lost, right? I mean, because the architecture is totally different at both the places. So that's one thing that you probably want to look at, and not make it too complicated, right? Okay. So there are few more examples that I might want to bring in here. Like, I mean, for example, you want to use a monolithic service versus microservices, which to use. Probably you should look at it right at the time and probably put it into that scalability factor that I had mentioned. Layered architecture again comes into your scalability and simplification, right? I mean, both these will come into that also. Event-driven systems, for example, the Air India thing that I was talking about, it required queuing because the volume of data that used to come in. But that doesn't mean that all of them require queuing system, right? So if it is something where you have got large volumes of data coming in from a third-party system, probably you will use queuing system. But if it is not, if it is, as an example, like, I mean, if you're building something which is Jira based, you want to create something similar to Jira for your own organization, you don't need things like queuing systems, and you don't require things like microservices on that, right? I mean, unless, now again, contradictory to that statement, if it is going to scale, probably you don't require still microservices. You will require microservices in there if you're scaling it to a higher level, but no queuing system is required. If you require a queuing system later, where in your product, if it eventually becomes a product and then connecting with third-party systems like other GitHubs and all those things, yes, then you will require a queuing system. Create it as a separate product and create it as a separate architecture, right? So that is how I would put it, right? Real world tip that I would have is start simple, refactor towards complexity only when it's needed, right? So that is how I would put it. Building with the future in mind is what you should probably consider when you're architecting it. Think of the team size that is going to be there when you're architecting it. If you over-architect it, you will require a bigger team, which might not be a good idea. Deployment models, right at the time of architecture. Are you going to do on cloud or on-prem? Expected user growth, the traffic that is going to come in, that is a very important factor. You have to keep it in your mind always. Integration needs that you have, and of late, with everything going on cloud, you should always consider 2 things when you're architecting it: mobile first and API first. These 2 factors have to be in your thought process when you're architecting everything, right? Okay. So closing note, great architecture isn't magic. It is intentional. It is thinking long term without slowing down today. Keyword, right? I mean, it is long term thinking without slowing down today what you're developing. sort of an agile concept, but in a different way when you talk about architecture, right? As you architect your project, ask yourself, what will this make sense a year from now? Because most of the products that you are going to build today will see the light of the day probably in 6 months, 7 months time. Whatever you're bringing in today, will it make sense after a year? Keeping in view, looking at your team size, your deployment model, your expected user growth, your integrations that you need, right? Okay. The best architectures are grown, not built. Okay. This is a quote I read somewhere, right? So just keep that in mind, right? When you're actually building it, don't forget that when you are actually building or architecting something, that is something like you're building a house. This is very important. Keep that in mind, right? Okay. If you have not seen the episode 1, I have put the links across at different places. You can actually go and see it. And that's it from me for this video, right? This is Menon Thoughts signing off. Until we connect again, keep learning, keep caring.